today we'll try to wrap up whatever's left from capacitors. We have the discharging graph, the equation, time constant, these three. Okay, so let's start. Last class in the extra bit of the class, I explained capacitor combinations out there. So it's a standalone topic. It's not like it's going to hamper anything we're going to do today, but just bole rakhi, capacitors can be combined in series and parallel. You need to know what's the equation for the combination. And more importantly, you need to know what's same and what's different about them. So I'll just, again, add on the side. You guys tell me, what is same for series combination of capacitor? Like what's same in the capacitors? Charge, okay? So same hoche charge stored or charge. And what's shared? Voltage, okay? So voltage is shared. So yeah, this is the thing that you need to keep in mind. Just in case you forget, you can use this to figure out what's happening. And parallel, I think, should be easy as well. What's same for parallel? Yeah, voltage. And what is shared in the branches? Yep, so shared charges. Turn off. Acha, itu kichwan chalo. Ready? এখন আসছে All right, so let's move on. I did a question here. A question out figuring out how much is the charge here. We'll come back to it. Ask I just want to go into the discharging right away. Okay, so 112 and 113. Again, 112 to বুঝার চেষ্টা করি. What is charging and discharging of a capacitor? So let's try to understand. This is a core topic. You have like a separate division for this in your syllabus. Right, so you have a capacitor here. First, we'll learn how to charge it, and then we'll discharge it. So the syllabus focus is discharging. Okay, just keep that in mind. Charging arrow graph, charging arrow, logic exists. They're not really interested in that. So yeah, you have your capacitor here, and the capacitor is right now getting what? I've connected my capacitor to a power supply, right? What is the capacitor becoming? Charge, right? So what actually happens here is that inside you have particles that like electrons, they're moving like that, and they're eventually stacking up here, building up there. So this is the charging of your capacitor. Okay, now can you remind me how long will this process take place before the charging process stops? Yeah, so you have V here, V total, and this V total to the same way the charging process stops. This is called a charged capacitor. So what you have here is a charged capacitor. Charged capacitor. Just for the sake of revision, we'll just go through the equations for it. Can you tell me how to find the charge on a charged capacitor? Right, very good. Q equals to CV. How do you find the energy stored in your capacitor? Right, half CV square or half QV? Okay, half CV square or half QV. So yeah, this is what we have done so far. On the last couple of classes, this is what we did. You have this charged capacitor. What you want to do is you want to discharge it. So how do we discharge this into the key? So to discharge a capacitor, so discharge করার জন্য যেটা করতে হবে হচ্ছিল disconnecting the power supply. Actually না. So if I disconnect the power supply, let's agree with what you said. We disconnect the power supply. Do you think the capacitor will get discharged? just because I disconnected the power supply? No. Yeah, the circuit is not complete. So discharge a capacitor, what you need to do is you need to connect it through another circuit. And ওই সার্কিটটা ধরো একটা রেজিস্টার দিয়ে start করলাম, just to be simple. So as you connect your capacitor through a resistor, what will happen is your capacitor will get what in this process? Discharge. Discharge মানে কি হবে? Charges গুলো এখান থেকে বের হয়ে এভাবে করে চলে যাবে. Now we found that while it's discharging, there are a couple of things that happens. Number one হচ্ছে there's what provided by your battery here or your capacitor, a potential difference, right? Unlike a normal battery, when a capacitor discharges, what happens to the voltage? Like a normal battery, when you're connected into a circuit versus a capacitor, when you connect to a circuit, right? What happens to the voltage? Decreases. So what is happening is that as the current is flowing, simultaneously V is going down. As a result, you don't have like a flat DC current anymore. Remember direct current? Direct current is only possible if you use what kind of a supply? Like a battery, normal battery. But the voltage is going down. And because the voltage is going down, what should naturally go down with it? The current, right? Charge, current, and everything. So we have something here that will help you figure out the current that's flowing through the circuit. So to find the current that's flowing through the circuit, what do we use here? We use V equals to IR. We'll just assume that this is a power supply. We'll have a resistance here. I'm going to keep the current. But unfortunately, এখানে ভোল্টেজটা কমতেছে, তার জন্য কারেন্টটা কি হতে থাকবে? কমতে থাকবে. Now, how does that look like in the form of a graph? That's what our topic is about. So আমি যেটা আবার repeat করি, we charge the capacitor. Now we are discharging it. How does the current and everything vary? There are two approaches here. One is a qualitative approach. One is a quantitative approach. Qualitative approach, you need to say why is the current vary, and quantitative approach, you actually have to find the current that's varying. You have to do math. Okay, so how do we do this qualitatively? In terms of the physics and the logic, what happens to the current as it discharges? So let's try to see. It's easy. I think Nora Parva. So we'll start with the flow of charge. That's the easiest one to look for. Okay, so let's say we have a circuit provided here. My capacitor right now is fully charged. So if my capacitor is fully charged, what is it indicating? Capacitor fully charged mane ki? Is there a limit to the number of charges your capacitor can hold, or there's a limit to something else that a capacitor can hold? Electrons. Potential difference. Oh, sure. That's the maximum capacity. Then I'll repeat my question. When you have a capacitor, right? What's maximum for it? The amount of charge it can hold, the amount of energy it can hold, or the amount of voltage it can hold? Energy. Maximum amount of energy. Why would you think so? Energy the formula camera E equals to half CV square. Why are you thinking that this is going to be maxed out? Capacitor is fixed. So as it is highest, what's the highest voltage? Oh, depends. So energy controls the voltage, or the voltage controls the energy? Yeah, it's a battery. So I'll tell you, capacitor কোনো limit নাই. Capacitor limit কি? তুমি যেটা voltage দিবা, you keep increasing the voltage, it keeps increasing the amount of what does it store? Energy, right? তাহলে কি, can I take any random capacitor and just fill it up with as much voltage and energy I want? Unfortunately, no. Turns out তোমার syllabus এটা নাই, but এটা তোমাদের diode শিখে আসলে এসে that at a certain pointer পরে গেলে, what does your device do? Diode যেও same ছিল. Do you know diode? Semiconducting diode, it allows current to go one way. উল্টা দিকে কোনো current flow করে না, একটা পয়েন্টের পরে কিন্তু কিছু একটা হয় উল্টা দিকে. Do you remember? Yeah, it's called the breakdown region. There's so much current trying to pass through it that the diode কি করে breaks down, right? So তোমাকে দেখাই, it's related to this topic. So আমাদের নোটসই দেখাই. No, I just lowered the fan. Right, so কোনটা আমি বলতেছি আমি দেখাই তোমাদেরকে in your electricity chapter. এটার সাথে relate করতে পারবে, তার জন্য দেখাচ্ছি। এই যে, do you remember the graph for a diode, right? So graph in a diode is like the forward at 0.7 report, it starts to conduct, and as you go the other way, there's reverse bias. No, current conduction at all, and then suddenly there's infinite amount of current passing through, right? এটাকে কি বলা হতো? Breakdown voltage. What did it mean actually? It meant that if you cross that value, the thing, like, structurally break down for it. It can't just block it anymore. It's like, the dam of a river. It can block a certain amount of water, right? It's very similar to that. Similarly, in a capacitor, there is a similar feature. So capacitor economic charge gather and they can't go the other way, because who's holding them back? The dielectric, the insulator, right? But insulator to infinitely insulative na. They have limits. At the point of the charge jump curve and you'll have a spark. And that's what happens when you use capacitors. So in the lab night, so you guys are safe. Capacitor causes the most injuries in a lab. Karon capacitor could be easily overheat and it explodes. When it actually explodes because the amount of energy in there suddenly released. So there's a spark, there's a smoke, and it like breaks down, right? So the point I'm trying to make here is that the amount of charge it can store, the amount of energy it can store, it depends on how much, what do you do, the amount of push you provide, and the push is known as what? Voltage. Okay, so bigger battery, the beshi push did, so more charges can be pushed to the top, more energy can be stored. But is it infinite? No, because at a point pore ki hobe, it'll break down and it'll like stop working. So yeah, we have our charges here. So right now I've stored charges here, electrons, and my capacitor is charged right now. So there are plenty of electrons here. This is referred as a what capacitor? Charge capacitor. On the other side, it's devoid of any electrons out there. So a side ta jodi positive charge hoy, a side ta negatively charged. What are we going to do right now? What we'll do is we'll connect this to a circuit so that my charges can freely flow. So আমি হচ্ছে এখানে একটা short circuit create করলাম for our first example. যদি short circuit create করি, in theory, right, all the charges will just flow instantly because there's absolutely no what available, resistance, right? This you should never do in a lab. So in a lab, whenever you discharge your capacitor, number one rule হচ্ছে discharge it through what? A resistor, a component, something, okay? Because otherwise the current will be too high, it'll actually melt your wires. So we have a resistor right now. So this resistor is what is discharging through. So first question for you, okay? I'll make it intuitive, easy. I have electrons here, and the circuit is right now open. What are the electrons trying to do to each other? Repel, right? And right now they're all trapped in that one side out there. So the amount of repulsion that they're experiencing or exerting is what amount? The highest. Okay, they're just very eager to leave. Okay, so they just want to go away from here. So the moment you connect the circuit, right, one of the electrons makes its way out first. Lucky or unlucky, I don't know, but first this electron that comes out first, right, is facing the greatest amount of what from the electrons outside? Repulsion. So wouldn't this be the fastest electron out there? So the first electron will be the fastest, which will mean the rate of charge flow is the greatest. And that means when you discharge a capacitor, the first current that you register is always going to be the what current? Maximum current. So capacitor discharges শুরুতে সবচেয়ে বেশি current থাকে. Then যেটা হবে, this electron is gone, and this thing is now more negative or less negative than before? Less. So the other electrons that are going to come out right now, they will actually not find it that repulsive, right? So the repulsion একটু কমে যাচ্ছে. So gradually what's going to happen? The amount of repulsion is going to go down, the rate of flow is going to go down, and as a result কি কমে যাবে? Current. Now imagine all of them are gone. Like the whole capacitor is just one electron left. This one electron barely has any repulsion, right? In fact, it's relying on the what from the other side? Attraction. Wouldn't that take awfully long time to get the other side? So last dige current almost ki hoye jay? Zero. Ajke amra dekhbo, this is a problem. Problem keno? A capacitor will mathematically never fully discharge. Because if you do the math, time must be infinite. Okay, so what do? Do we wait forever for a capacitor to discharge? No. So there's actually a way to figure out how long do you need to wait practically. Mathematically, how long do you wait? Forever. Okay, we'll do the math. You'll see that there's no solution to the time. But practically, there's actually a time. Wait, time today, we have a lot of applications we'll see today. For example, smoothing ball how you make an AC into DC supply, the approach, how you make timers. Okay, so before I get into that, are you clear about this, what I just explained? So if I translate this information to a graph, মানে আমরা নিজেরা একটু investigate করে চেষ্টা করি গ্রাফটা কি হতে পারে. So if I translate this information to a graph, what kind of a graph can we expect? So শুরুতে charge, right? Coulomb and time. শুরুতে the charge is going to be discharging, right? The charge is going to be what at the start? Maximum. So I'll start with my maximum charge. And the charge will move out at the greatest rate at the start. So the graph is going to be decreasing at like should be like this, decreasing at an increasing rate or decreasing at a decreasing rate. Yeah, decreasing at a decreasing rate, and you'll find that the x-axis is actually an asymptote. So erom kore meet korbe na, and that is the graph for discharging. Okay, now this is the graph for what? Charge. But we know that Q equals to what? CV, where capacitance is constant. Then how does charge and voltage relate? Directly proportional. So how the graph for voltage look like? Exactly same. Okay, so that's where I'll add the 3 graphs here. So একদম same হবে voltage এটা, and আরেকটা জিনিস দেখাই তোমাদেরকে, voltageটা পরে দিচ্ছি. What does the gradient of the graph give you here? Current, right? So the highest current is at the start, সেটা current 0 হয়ে যায়. So you can say that this is the graph for what as well? Current versus time. Now, if I want to find out the voltage, আমরা জানি Q equals to CV use করতে পারি, but there's another way out there. Through the resistor, if I want to find out the voltage, what is the formula for voltage across a ohmic conductor? V equals to IR. So V is completely dependent on the variation of what in your circuit? I. No, V equals to the IR করি, আমার current যেভাবে change হবে ওভাবে voltage change হবে না. So this is a graph for my current, right? Wouldn't that also mean it's the same graph for my voltage? So eventually, a simple thing for most of chemistry students is that you only have discharging graphs, and all the 3 discharging graphs look what? Same. Okay, so this is how the graph looks like. এখন what's the equation for this graph? So এটার derivation exists করে, I mean last year derivation মানে দেখাইনি, তোমাদেরকে দেখাবো না, I just want to confirm. Derivation is based on integration, which I think is not really something তোমাদের দেখানো উচিত. You lose your mind. So it's there in the Excel syllabus. আমি তোমাদেরকে একটা just জিনিস দেখাই momentarily. So there's a derivation which will lead to the graph equation. যে গ্রাফগুলো আমি ড্র করলাম ওটার equation. Derivation দেখো স্ক্রিনে here. The equation for discharge, right? So এটা হচ্ছে Kirchhoff law use করে, integration use করে, তারপর limit set করে, finally we come across this. So তোমাদের luckily Cambridge হচ্ছে, you directly jump to this equation. This is called the equation for discharge. Q equals to Q naught e to the power minus T by RC. Okay, you'll again have this equation in your A2. There's another chapter called radioactive decay, and surprisingly radioactive decay যেভাবে decay করে exactly same bhabe what else also decays? A capacitor charge. So capacitor, and this is something very unique in nature. I'll give you 5 examples. There are many more. The way a charge goes out of a capacitor has the exact same equation as how a radioactive element decays in an atom, has the exact same equation as how water pours out of a burette. In a burette, right? You open it, water পড়ে, ওটা যদি graph plot করে দেখবা যে it's the exact same equation. শুরুতে rate অনেক high থাকে, আস্তে আস্তে die out করে. This is the exact same equation for the way amplitude decreases in an underdamped scenario. We have done that, remember? Simple harmonic motion mode, the graph going down like that. So this pattern, right? It's basically nature's way of decreasing things. Whenever you let nature do things, right? Naturally, this is the function they follow. It's basically x equals to x naught e to the power minus some constant. এটা minus t by RC এখানে, minus bt কোনো এক জায়গায়, minus lambda t এক জায়গায়, but this pattern is the same, which means almost all the decay equations that we have in our physics, science follows this pattern. What is the pattern? So আমি একটা generic pattern বলি আগে. X equals to x naught e to the power minus some function, okay, kt. This is the general equation. এটা থেকে use করে for our scenario we have 3 equations. So the one for charge would be what? Q equals to Q naught e to the power minus T divided by RC. এখন এই T by RC কোথা থেকে আসছে? I think it's not needed because it's a complicated derivation, but you just have to know the equation. Similarly, I can use this equation to come up with the equation for current, which is going to be what? I equals to I naught e to the power minus T by RC. And lastly, হচ্ছে voltage or potential difference, V equals to V naught e to the power minus T by RC. These are the three equations that you can use to find out how the charges and the voltage and everything changes in a capacitor here. So that's the three graphs that we have here. So to এটা দিয়ে কি করতে পারবো? Some students know the equation, but they're not aware of what can you do with this. I think you're at the stage 8 to একদম শেষে. You should know what you can do with it. Can you tell me what can I do with this equation? Fine. Just that. Right. And resistance. Acha, R. I mean, just all the unknowns. You can find all the unknowns there. You can find I, T, R, C, সব কিছু। আমি কেন এটা বললাম? I know it's obvious. You're thinking that এটা জিজ্ঞেস করার কি আছে? এক্সামে কোনো একটা question দিলো, they'll say find resistance in this circuit. And students never look into this equation. They're looking V equals to IR. They're looking into other equations out there. But this is also possible to find R. If you know I naught C, right? And you know time from the graph, can't you find the R? So, look for these equations and try to understand what can they do, okay? So yeah, they're not just limited to current. They're limited to everything that's available where? In the equation itself, okay? So yeah, these are the three equations out there. These are called the discharge equation. কোনো question থাকলে আমাকে বলো if you have any clarification that you need. So I'll add some notes here to copy right now, and then we'll try to do some math. So I'll try something there. It's now pointed downwards. I think. তোমার কাছে যাচ্ছে? তাহলে প্রবলেম নাই। So বাকিদের কাছে যাবে না। Right, so these are the three equations. I'll add like a side note here. কেমনে আমরা এখান থেকে ওইখানে গেলাম ওটা দেখ। তাহলে মাস্টারমাইন্ড এক্সাম ডেট করবে? আমাকে একটু third physics paper. Uh, 24. আর 23rd এ 23rd হচ্ছে পেপার 4 আর হচ্ছে 26 হচ্ছে আচ্ছা আর গ্লেনারিস এক্সাম কবে? No date. Did you have like a tentative idea? End of November. And syllabus is till AC supply. Magnetism is fully there, right? AC currents. Yeah, I mean, I think the last day somebody said it's still nuclear physics, quantum physics. Achha. You have paper 5. I'll make it colder. So yeah, we'll again have class extended on Wednesday. আমাকেও ক্লাস নিতে হবে। It's a lose-lose situation. হ্যাঁ, ক্যাপাসিটর আজকে পুশ করলে মোটামুটি হয়ে যাবে। আরেকটা ক্লাস নিব আমি, but I want to like rush through magnetism. Rush না, মানে I want to start magnetism. ম্যাগনেটিজমের পরে যদি কোনো টপিক থাকে ওইটা মেবি ওরকম ফোকাস করতে পারবো না, জাস্ট আই এম নট রিয়েলি শিওর কি আছে, বাট ওটার পরে যে চ্যাপ্টার গুলো আছে দোজ আর লিটল you know, you have never heard of those topics like quantum physics, right? So ওটা এক দুই ক্লাসে ওরকম বোঝানো যায় না। So what I'll try to do is I'll try to cover up till magnetism, which is like, you know, I think 95% of your syllabus, or to ভালো করে বুঝলে I think would be better. আর তোমাদের sorry, Nuclear physics হয়ে গেছে? Nuclear physics is the radioactive decay chapter, no? But medical physics and astrophysics. Yeah, have you done AC currents? ওই যে half wave, full wave bridge rectifiers.
At the start of the session. Yes, sir. Start of the session.
AC currents.
Yes.
How it's connected to like induction of
We started doing capacitors. Our experiment
আচ্ছা অসুবিধা নেই মানে at the end we'll all meet at the same place. এটাই important. Right, so শেষ এটা. Are you guys done? Okay. Right, so this is the equation. I can give you like a simple math to just see if you know how to solve exponential equations, but I think I'll get into the time constant first, okay? So এটা যেটা করবো, it's very fascinating একটা topic, মানে math based, but তার আগে এটা বুঝতে হবে. So are you okay with this? Right, so just quick reminder, what is this? I'll read the syllabus তাহলে তোমাদের একটু বুঝতে easier হবে, like ওরা চাই কি তোমাদের কাছ থেকে. So এই যে analyze graphs of variation of time with potential difference charge and current for a capacitor discharging through a resistor. Analyze graphs. So the graphs that we did. Okay. So graphs here, I've added some points. I don't know if you have noticed it later on. It's quite important. Okay. So number one, a graph gradient current, right? Our a graph shape will be the same as the voltage because which formula has been applied here? V equals to IR. Also, current highest value tissue depend on V equals to IR. Like you're given a circuit, let's say, a circuit, and you want to know what's the highest current that's going to flow through this circuit. What formula do you use? V equals to IR. Voltage konta use korbo, the highest voltage that was there originally, because voltage never stays the same, will keep going down. So for maximum current, you start with V max, and then you find the current. Okay, so that is it. Our area under the graph, yes, the area under this graph does give you actually something, because eta gradient jodi eta deয়, এটার area তোমাকে কি দিবে? Charge. Isn't the area under a current time graph charge? So did they ask questions based on this yet? No, but it is very, very popular in like the Excel syllabus. So to বলে রাখি তোমাদেরকে এখানে, if they ever ask you to find the charge stored in a capacitor, you can actually find the what of this graph area. Okay, and it's not going to be a fixed answer. What will it rather be? An estimation, because তোমাদের তো integration করতে দেয় না. So you're gonna find like box counting. When I say box count, okay. So area provides charge. You're not allowed to use integration. There's calculus allowed not so. That's to explain to you. কেন এক্সপ্রেশনটা এটা, তো তোমাদের বইতে ডাইরেক্টলি এক্সপ্রেশন দেওয়া আছে, কেন এটা থেকে এটা যাচ্ছে দেখা না. Okay, so why don't you have calculus out there? Because it's for your own benefit. Calculus যদি থাকতো, you wouldn't take physics. O level ছেড়ে দিতা, আচ্ছা like A level চিন্তাও করতে না. Calculus will make physics, that's how it should be, but ওরা promote করার জন্য to make students take more physics, right? They got rid of calculus. আচ্ছা, but calculus is how it's supposed to be in university. So অনেকে শক করে নেয় physics, like in A level, it's ভালো লাগছিল calculus ছাড়া, university গিয়ে they realize it's not for them. Okay, first semester, first class বুঝে, because তখন হচ্ছে they just bring calculus right away, তোমরা তো করো নাই, so you're always at the back end. So তোমরা যে কোনো university, if you take major as physics, right, first class you realize যে কিছুই শিখো না. That's how it is. Okay, unfortunately তোমাকে নিজে থেকে একটু catch up করতে হবে. Okay, because you're doing like a very easy version of the physics, like the math ছাড়া যে version. Okay, anyways, let's move on. So time constant জিনিসটা কি? Right, কিছু লেখো না, এটা বুঝো, এটা একবার বুঝলে I think ভুলা যায় না. It's actually খুব easy একটা জিনিস, but important as well. So what I'm going to do right now is I'm going to make my capacitor discharge, and I will make my capacitor discharge. এখানে হচ্ছে charge, current, কোনো কিছু ম্যাটার করে না, সবগুলোই সেম হবে. So I'll work with your voltage here. So কেন voltage আমি একটু পরে বুঝাচ্ছি. So voltage দিয়ে start করবো, and my system starts with a maximum voltage here of V naught. Okay, that's my maximum voltage. So yeah, we will make this thing discharge. So I think you already know, if this is against time, what should the shape be? How do you describe it? Right. Decrease in error, decrease in rate, right? So decrease in error, decrease in the general shape would be exponential, but it's decreasing at a decrease in rate. So that's how the graph is supposed to look like. Now this is randomly moving down like that, right? And then suddenly somebody figures out, wait a second, what's the equation for voltage discharge? V equals to V naught e to the power minus t divided by RC. And this is actually not true story, but the thought process was something like this. So the thought process was, if you look at this equation, এখানে একটা constant আসছে, which is what? R into C, where R is the what in your circuit, the resistance, and what is C? Capacitance, right? So somebody wondered এটা কি unit হতে পারে? So RC যদি আমি base unit বের করতে চাই, right? কেমনে বের করব? Base unit. Do you remember base unit, derive unit? So I want to understand, what does RC actually give us? Like, what is it? Base unit বের করা কিন্তু is one of the best ways to figure what does it actually mean. Okay, so resistance এর জন্য একটা formula বলো, V equals to IR. So IR, V equals to IR. So R equals to V by I. And but V equals to I দিয়ে করা যাবে, and capacitance হচ্ছে Q equals to CV. So C equals to what? Q divided by V. And আমি যদি এটাকে further breakdown করি, আমার এখানে হচ্ছে V by I times Q equals to what? IT, like from all levels, right? I'm using একদম basic idea here, okay? Divided by V. Simplify যদি করি, V cancel out হয়ে যায়, I cancel out হয়ে যায়, কি রয়ে যায়? T. So it turns out RCJ product, resistance and capacitance J product, it actually gives you some time. Coincidence maybe, right? But it gives you a time. So somebody wondered, a time টা যদি আমরা হচ্ছে use করি in my circuit, right? And I wait for this time, কি হতে পারে? It seems interesting. It gives you some time, right? What happens at that time? Let's try that out, okay? So what they did was they put this in V naught e to the power minus t. So t টাকে কি দিয়ে replace করছে? With RC. মানে we are going to wait for the time that's equal to RC. তোমরা কি বুঝছো what I mean? কারণ আমি যদি R into C multiply করে দেখি 15 seconds, I want to know what happens at 15 seconds. So I'll put 15 seconds in my equation. So এখানে RC provide করবো, divided by what as well? RC, which becomes what? 1. So therefore, it turns out V is equal to V naught divided by what? E. Turns out, if you wait, listen carefully, if you wait for a time equal to the duration of RC, any time in your discharge process, the value decreases by 1 by E. মানে হচ্ছে আমার যদি 15 seconds আমি যে কোনো জায়গায় ওয়েট করি in this entire process, how much would my charge decrease by? 1 by E. And that's exactly what was there in your radioactive decay with half-life. Half-life was the average time taken for a sample's activity mass or something to become what is initial value? Half, right? Capacitor also has the exact same feature, but instead of half, how much does it become? 1 by E. So despite there being randomness in the process, we find that if you wait for a time that's equal to RC, let the value be anything. If you wait for a time equal to RC, the value will always decrease by 1 by E, which I need your assistance from calculator to check for but how much percentage is that? 1 by E করে into 100% করো. Any জায়গায়. 1 by E. How much is it? Oh, they said 36, like 96. Oh, I had 36. Yes, I heard 96. Right. So 36.7%, 36.8, right? 7.8. Okay. So you know what happens here? Ekটু দেখো screen. We're not done. We're not even halfway there. একটু দেখো আগে কি হচ্ছে. So we find that if you wait for a time of V naught, if you wait for a time that's equal to how much? RC. When time টা is equal to RC, you'll find your value has gone down by how much? An E fraction. Okay. Now, what if I wait for 2 RC? Instead of waiting for 1 RC, I wait twice for that amount. So if I wait for twice that amount, I get B equals to V naught e to the power minus 2 RC. 15 seconds জায়গায় কত wait করবো? 30 seconds, right? তাহলে আমার কি আসবে এটা? V naught e to the power minus 2, which is V naught divided by E squared, right? Achha, can you check in calculator what's 1 by E squared into 100? 13.53. Achha, okay. So that again will happen if you wait a time for how much? RC. So প্রত্যেকটা RC তে your subsequent value is becoming how much of the previous one? 1 by E, right? So এরকম করে কমতে থাকবে। And আমি নাম্বারটা আবার একটু জিজ্ঞেস করে তোমাদেরকে say like this is, so the one that came here was 36.8%, right? আর এটা হচ্ছে V naught by E square, which is 13 point how much? 13.53, so 13.5%. What's V? So পরেরটা guess করতে পারো কি হতে পারে? E cubed, right? How much is that? 4.98. আচ্ছা, okay. আচ্ছা, so আমাদের হচ্ছে from the initial 100%, we have come down to how much suddenly? Only 5%, right? So আমরা আরেকটা try করি. I will make you do it 2 more times, so তোমরা আগে থেকে বের করে রাখতে পারো। So যে এই জায়গায় যে আমরা থামবো, okay? So this one is again a time equal to what? RC, and that is again equal to a time equals to RC. আচ্ছা দেখি। So yeah, this is going to be how much? V naught by E to the power 4, and that's V naught by E to the power 5. Can you tell me these? 1.83. 83%, and what's 0.67%? Just for the sake of science, what's 1 by E to the power 6? When 5 can thumb up, so E to the power 6 start to take it now. 0.24. Acha, okay. So এটা হচ্ছে পরেরটা আরো ছোট হয়ে যাবে। So yeah, we started with how much, by the way? একদম শুরুতে 100%, and that's 100% here. So আমি নাম্বারগুলো size দিছি to give you a idea of how much change is taking place. So you initially started with what? Full 100%. তারপরে in one time constant you went down to how much? 36. It's that, and then it keeps going down and it's 0.67%. Why did I explain this? So let me tell you what's the logic and reason behind doing this thing. So time constant helps you figure out how long you should wait for a capacitor to be considered fully charged or discharged. I'll explain why. Remember, we said mathematically it's not possible to find out how long you should wait. তোমাদেরকে যদি এখন কোনো equation দেয় আমি তোমাদেরকে জিজ্ঞেস করি find the time taken for it to completely become 0, right? A math error আসবে। Like I think natural logarithm of 0 or something. Okay, so কিছু আসবে না স্যার। তাহলে আমি যদি practically wait করতে হয়, how long do I wait to consider my capacitor fully discharged? The answer is like an internationally accepted value, 5 taus. So তোমার যেই ক্যাপাসিটরই হোক, যেভাবেই কম্বাইন করা হোক, how long does one wait for a capacitor to fully discharge? 5 time constant, okay? So fully discharged or fully charged, okay? So fully discharged is equal to 5 time constant. By the way, আমি tau বলতে ভুলে গেছিলাম তোমাদেরকে কি। So 5 time constants, and ওই time constant থেকে আমরা একটা symbol দিই, it's called tau, and tau is what we call the time constant of a capacitor. It basically tells you the amount of time needed for your capacitor to go down to what value? 1 by E of its what value? Original value. Now you might wonder, কেন 5 টাউতে যে আমরা থামলাম? কেউ কি আমাকে বলতে পারবা কি হতে পারে? Some of you did the math. Why did I stop at 5 tau? Yeah, so there's something called diminution returns. So প্রত্যেকটা টাউতে, look at the change in the first tau. Isn't that massive? It's like 63 point something percent কমে গেছে। তারপর it's not bad. It's like 20 কমছে, তারপর কমছে and কমলো। But once you get to 5, 6, 7, 8 taus, right? মানে ওই ভ্যালুগুলোতে you'll find the changes are very negligible. So by 5 tau, we can consider our capacitor to be what? Fully discharged. Okay, why don't we go till 6? Yeah, so 6 যেতে পারো, problem নাই, it'll just be more discharged, right? But on your device, what are you using to see voltage? Device key voltage দেখার জন্য voltmeter doesn't really have decimal places enough to show that small change anyways. So তোমার voltmeter already কি show করবে by 5 tau? 0, right? So if you have like a really sensitive I don't know, micro voltmeter যেটা probably exists করে না, তাহলে maybe change দেখতে পারবা। But আমরা তো millivolts এ calculate করি most of the time, not even millivolts, we just do volts with 2 as my reference, right? ওইখানে 0 হয়ে যাবে by 5 tau. So 5 tau is the time taken for your capacitor to fully discharge. And before that, one more thing, what is tau? So tau is the time taken for your capacitor's current, voltage, charge, any quantity to become what the initial value? 1 by E. Okay, 1 by ETH bola hoy. So that is what tau is. You get my point? So এটা use করে অনেক prediction করা যায়, estimation করা যায়, because you know that কত tau লাগতে পারে. By the way, charge করার জন্য কতটুকু wait করলে enough? Same. আচ্ছা, because তুমি একটা পয়েন্টে দেখবা charge till 99 point, মানে 100 minus এটা করলে যা পাবা 99.97, তারপরটা হচ্ছে 99.998, মানে it changes very little towards the end. It'll never become what the 100. আচ্ছা, তুমি যদি 5000 tau wait করো, it will never be 100. It'll be just very close to 100. So there's no point in waiting for it. Okay. See, I'll add a note here to copy করে নাও, এটা শেষ করে ফেলো আজকে, because capacitor এটা দিয়ে শেষ। স্মুদিংটা আমাদের হচ্ছে AC current চ্যাপ্টারে আসে, so স্মুদিংটা আমি AC current-এ করাবো, because we need to learn how to rectify first. Rectify পারো না তোমরা। Yeah, just copy this note and then I can start magnetism next class. So yeah, 6 tau, 7 tau কিন্তু wait করলে কোনো problem নাই, আমি just আগে heads up দিয়ে রাখলাম। But my question is, why should you wait? Discharge তো হয়ে গেছে in terms of practical application, right? So আর লাগে না। Fully charge and discharge হয়, but I mean discharge এরকম is your syllabus focuses on discharge. Charging equation দিয়ে রাখবো, last year স্কুলে এক্সামে charging equation দিছিল, কোথা থেকে question আসলো আমি জানি না, but দিছিল, so দিয়ে রাখবো। It's not in your syllabus, it's an Excel question. Oh, IB. New teacher. And IB থেকে। What's wrong with your questions? তোমাদের তো 25 years worth of খুব ভালো question exist করে, and it's relevant.
Sir, last class you did some graphs at the end.
Yeah.